Okay, this is Linux Chapter 1, Part 1, and we'll just talk about some of the things that you really have already, or should already know. The second slide talks about operating systems, understanding operating systems. So what we end up doing here, the operating system is the go-between between the application programs, the users, the programmers, all of those, one part, and all the peripheral devices. Okay, so you as the user and all the peripheral devices. So the operating system runs the hardware, the CPU determines, gives out resources to applications. The monitor, of course, we look at that. Keyboard, mouse, a printer, all of those kinds of things. So the operating system acts as the go-between between the two. Now, lots of different kinds of operating systems. You have Linux and Unix, which is what we're talking about, but you also have Windows 7, Windows 8. You have Server 2000. In the server environment, you have Server 2008, coming Server 2012. Linux and OpenSUSE and a lot of different versions of Linux are mainframe are network operating systems, and then you have mainframe operating systems, which are like the IBM systems and some large Unix systems. So PC operating systems, again, personal computer system or PC stands usually a standalone machine. Your notebook, your desktop, your mobile device, for instance, is running an Android system or an Apple OS as well. And then a platform, though, this is the important part of this slide. So a platform is a combination of hardware and operating system. So a platform might be a certain kind of PC with Windows, or a certain PC with Linux. And when I mean certain PC, a certain kind of PC, is it an Intel box? Is it an Apple server or a Apple computer? Is it like an IBM or like a mainframe computer that may be produced by IBM and running a Linux environment or an IBM OS? So that's what a platform is the combination of hardware and software. Now the server OS and networks. This is what you see as typically a client-server environment. And that's like the internet, basically. For instance, that's like most of your network operating systems. Now a server will house applications, network operating system, file service areas or file areas, and the clients will go ahead and access those. Now this could be a client with a web browser on it and the web server on the server. Okay, so that's one kind of scenario where you might have a client-server environment. The client, think about when you register for classes through the web. You're acting as a client here, but you're actually accessing through the internet those resources on that server. Now also on campus, if you're on this client and you're on a desktop computer and you're tied physically into the network, this is the wiring, the UTP wiring that will go out directly to your server on campus if you're on a desktop. So you may save a file on a file share. That file share is actually physically here on the server, but you are saving it out to that file share. On this particular client, now we're going to imagine that this wire is gone. This is your wireless client, and so when you go to Helena College, you sit down, you log on, you're still, whether you're accessing it through the web, whether you're accessing, and as a guest you can only access through the web, I believe, but you can access your email. You can access your email. You can access Moodle. You can access all these things wirelessly, but you're still a client. The server is still serving out Moodle, for instance. Now, keep in mind, Moodle is actually a cloud service. So that cloud service is way over here on another computer, tied together through the internet. So we have to use some imagery and imagine this, but this is the Moodle server, East Coast, I think, and it's tied together to our servers and to your clients through the internet. Now, A computer network lets PCs share resources. Now, not just the server is out here, but you notice on campus printers are out here as well. These clients can access printers through the server and out to the printer. Client server is a server OS controls the operation of a server which accepts requests from clients. Think about that. Did we give examples of that? Now, let's see, a peer-to-peer network, we really don't see those anymore, maybe in a small business, but peer-to-peer networks are an alternative to server-based networks. So each system on the network is both a server and a client. So basically, imagine that this server is gone and you have all of these boxes tied together, and this can be a database server, this can be a client for that database. This can be a web server, and this can be a client for that web server. And you can have combinations, and let me go one step further with that. This was a database, this was the web server. This box can be a client to this server's or this computer's database server. So you can have all kinds of combination in a peer-to-peer network. Think about this, and there are a couple of issues with client-server environments. First of all, it costs more to put together a client-server environment. That's the downside. There are some other downsides. But think about, where do all these folks save their data in a client-server environment? Right here. Where do you back up that data? Right here. Now, let's think about a peer-to-peer network. Each one of these are peers. Where do you save your data? Where do you back up your data? You back up this client's data on this computer, this client's data on this computer. Now, from a perspective of an IT network administrator sort, what kind of problems does that create when you're starting to back up data from 100 different computers? Not just 4, but 100 different computers. The job on this server is way, way easier than a peer-to-peer network. Okay, now talking about Linux and Unix. So Linux is a Unix-like operating system. Not written from a traditional Unix code, the kernel created to look and act like Unix. And Linus Torvald released it free of charge in '91. So Linux is a open source operating system. And open source meaning that you can go ahead and you can access it and use it and work with it for free. Now that doesn't mean with some open source programs that they don't charge. What they're charging for oftentimes are the media, packaging, support, things like that, so that you can anyway, that's what you're using open source for and Linux for. So let's see, there are many distributions available. Red Hat, that's one of those you see as mostly a for-pay kind of open source program. So let's see, and then we have OpenSUSE, which is what we're using. Ubuntu, we've used that in network security before. So that's a good version of Linux. Now, a shell is a program that interprets commands you enter from keyboard. So typically with Linux, we're going to use a bash shell. And when you log on to Linux, the operating system is sitting over here, but that shell is what you actually log on to. So the commands that you're entering are from within that shell, are executed from within that shell. Now, we're using a command prompt, but there's also the graphical user interface, or a GUI. And if you install Linux into a virtual machine, and I'm looking to put all that stuff together, but if you do that, you can use the GUI, kind of like a Windows environment, but you'll be doing your assignments from this command prompt, this terminal window. Okay, so as it says, we'll be working from a command prompt all the time. Now, a brief history, you can read it, you can Google it, you can do whatever you want. Originally developed at AT&T Bell Labs. Now remember, this is Unix, not Linux. Unix was developed earlier than Linux. It was developed in the late 60s and 70s, distributed in source code. Let's see, in a couple of different kinds, a couple of different versions evolved. What we have is System 5, and we have BSD, which was developed at Berkeley. So Linux might be considered a more integrated version of Unix than its predecessors. Unix is considered truly a mainframe system. Linux is typically, yes, a mainframe system, typically though more of a network operating system, a single web server kind of system, and also a desktop system. So it really can be used in any of those scenarios. Now let's see, Unix and Linux OSs. So you can have Linux can act as a server, a client. It can be used with client-server workstations or standalone workstations. So with our web server admin course, we went and used Linux as the server, but we also used Linux as the client that accessed the server, and it worked really well. Now also I had a few years ago a really old notebook computer, half a gig of memory, 30 gig hard drive, and I forget the processor, but it was so old that at the time the Windows versions would work okay on it, but if you tried to put Windows Vista or Windows 7 on it, it wouldn't even hardly work. It would just crawl. Linux has a smaller footprint. So with that said, I installed a standalone version of Linux on the box, and really gave it a lot more life until finally some of the older parts all really wore out and it was a done deal. But due to the small footprint, Linux really works well on a variety of the small footprint and power. Linux works really well on a variety of different kinds of systems. It can be a multi-user and a multitasking system, portable, stable, reliable, versatile, and so on. Unix concepts, okay, so Unix shell is a command line interpreter or shell that provides a traditional user interface for the Unix operating system. Okay, so what we have here, the hardware, of course, the CPU, the memory, all that. Now, we have the Unix or Linux operating system. So the operating system sits there. And don't confuse the specific shell with the operating system. The specific shell is kind of like a program that you're running within Windows. You can kind of think of it that way. In this case, it's a command prompt that gives you a lot of power that's running within the Unix or Linux operating system, and then you have users accessing the Unix operating system through that shell. Okay, now Wine is an open source implementation of Windows API for Linux and enables you to run Windows programs on Linux. And I haven't actually ran that yet, but here's a short video that you could use to check that out. And then connecting to the Linux using Telnet or SSH. We've gone through that in a previous video, but basically you have to go out to the IP address, the IP name, and select SSH, and that's how your computer will connect to the Unix server. So at this point, I'll go ahead and start creating a separate video about the command set, and that's going back, that's a little bit about Linux, a little bit about Linux in a nutshell.